So exercise 4.2, we're trying to prove whether the intersection of two context-free languages is context-free. And the hint tells us to have a look at exercise 1. And the idea is we're going to pick one of the languages in exercise 1 that is not context-free and try and build it out of the intersection of two things that are context-free. So here's the language here I'm going to pick. I'm going to pick L4. And what was L4? It's a set of all strings of A's, then B's, then C's, where there's the same number of A's and B's and C's, and there's also at least one of each of them. Something like this. So we have to try and find two languages that are context-free, such that if we intersect them, we can get this thing here. So let's just brainstorm from it. So we know that this thing here is context-free, right? Because I can generate it with the following grammar, right? And I want to build up something that looks like this. So the way we're going to get away with it is we're going to write this thing as two languages, one of which enforces the same quantities of A's as B's, and the other which enforces the same amount of B's and C's. Okay, it's clear that L4 can be written as intersection of these two things, where this one forces A's and B's to be the same, and this one forces B's and C's to be the same. So now if I can just create a grammar for these languages, then I'm done. So let's look at how I can create a grammar for the first one. So here's my starting state. I want to go to a state that's going to generate matching pairs of A's and B's, and then I want to go to another state afterwards that generates as many C's as I want. So how do we generate matching pairs of A's and B's? Well, every time I make an A on the left, I'm going to put a B on the right, and my shortest string that's allowed has to be AB because the empty, I have to have at least one A and at least one B. So that's my base case. And then C can just make as many C's as it wants. Okay, so that's a CFG for this language here, and we can make another one for this language here in an analogous fashion. And so since we have CFGs for both of these languages, it indicates these two things are context-free, but their intersection is L4, which we already know from exercise 1 is not context-free. So the answer is no. Context-free languages are not closed under intersections.